Welcome to eMath. So today we will be looking at factoring or methods of factoring. And there are several methods of factoring. However, we will only be treating 5 of them in this module. The first one is the greatest common factor. So these are methods of factoring. Methods of factoring. Methods of factoring. Right? And as I said, we will only be looking at 5 in this module. So the first one is using the method of greatest common factor. Greatest common factor. So this method states that if you have an expression where one of the factors is common to all the terms in that expression, then you can simplify that by factoring out the common factor, right? By pulling out the common expression from the set of expressions. So if we have xy plus xz, for instance, then we can simplify by factoring out x, which is a common factor, and have y plus z there in the bracket. So that's what the greatest common factor method states. We are going to look at examples in a couple of minutes. Then the second one that we will be looking at is the difference of squares method. Difference of squares. Difference of squares. So this method is used, as its name suggests, when our factors are a difference of 2 squares. Okay, for instance, x squared minus y squared will be x minus y times x plus y. Right, that's the method of factoring difference of squares. Then the third one will be a difference of cubes. Difference of cubes. Right, this is also used to factorize expressions which are a difference of 2 cubes. So this formula actually says that it's going to be x minus y times x squared plus xy plus y squared. All right, that's the formula for difference of cubes. Then the fourth one, we have the sum of cubes. We have the sum of cubes, which says given the sum of any 2 cubes, you can also factorize that. All right, so it's going to be x plus y times x squared minus, okay? Notice the difference between these 2 expressions in the factoring of difference of cubes and sum of cubes. Don't get the signs mixed up. Plus y squared, basically. And then the last but not the least is going to be the trial and error. Trial and error method. So the trial and error method is mostly used to factorize quadratic expressions or quadratic form expressions, all right? Exact quadratic expressions or expressions that take the form of a quadratic. For instance, let's see. Now with the trial and error, it's going to be a little bit, okay, let's just x squared plus a plus bx plus ab. Okay, this is a typical quadratic expression. Then it's going to be x plus a times x plus b. Okay, so this will be seen more properly when we look at examples, basically. You can see this very well when we look at examples. So let's look at a few examples on how to use these methods of vectoring to factorize different algebraic expressions. Okay, we are still simplifying algebraic expressions. So we will be on to problems 0.5 of our reviewed textbook. Problems 0.5. Okay, so for those who are watching this for the first time, the textbook is Introductory Mathematical Analysis for Business, Economics, Life, and Social Science, 13th edition, all right, by Haeussler, Haeussler, and Paul. Haeussler, Paul, and Wood. Okay, the 13th and 14th editions. That's the textbook that we are using for this module, and all the problems we have been solving in all our videos are actually coming from this book. So when I say problems 0.5, I'm referring to the problems at the end of section 0.5 of this textbook. Okay, let me quickly look at number 1. So number 1 is factorize. It says factor the following expressions completely. So completely simply means you factorize until you can no longer factorize, right? Factor the following expressions completely. So the first one is very basic. 5bx plus b, right? So remember that terms are only separated by addition and subtraction signs. If there is no addition or subtraction sign between any two expressions, then all of that entire expression is just one term, all right? So this is a term in this expression. This is another term because there's an addition sign between them, all right? So B is common to both terms. Looking at this, there's B in this term, there's B in this term. So B is the greatest common factor. So the GCD method applies to factoring this particular problem. So it's going to be, take my B outside, I'm left with 5x plus 1. And that's the complete factorization of that. Okay, let's look at number 4 of the same problems, 0.5. It says 3x squared y minus 9x cubed y cubed, right? So again, the greatest common factor is applicable here, all right? The only way to know this is just to look at the expression and see that it's neither a difference of squares nor a difference of cubes nor a quadratic or a quadratic form. So all the other methods are excluded, and the greatest common factor is the only one that can apply here, because we can see a common factor in both terms, right? So the common factor there will be x squared y. X squared y is in this term. X squared y is also in this term. So if I factor out x squared y, from this term, I'm left with 3 minus, from this term, I'm left with 9. In fact, 3x squared y, right, is a common factor. 3x squared y and not just x squared y. 3x squared y is a common factor there. So 3x squared y is outside. So I'm only left with 1. All right, from here, minus. From here, I'm left with 3. 3 from this 9, because this 3 will multiply this 3 outside to still give me my 9. Okay. From here, x squared is already outside, so I'm just left with x. And y squared is also outside, so I'm left with y. 1 minus 3xy. Okay, and that's the complete factorization of that. Now quickly look at number 5. Number 5 says 8a cubed BC minus 12ab cubed CD plus 4b to the 4b to the power 4, c squared d squared, c squared d squared. Okay, so again, this is neither a difference of squares or cubes or sum of cubes or a quadratic that we can use the trial and error method. So the only method that can help us then to simplify this is the greatest common factor. So let's look out for common factors. So each of them, so this one has a cubed, this one has a, this one has no a. Okay, so a is not necessarily a common factor. So this guy has got b, this guy has got b, and this guy has got b as well. So b is a common factor. This one has 8 contains 4, 12 contains 4, and this one also contains 4. So 4b can already be outside. What else should be outside? This term contains c, this term contains c, this term contains c. So 4bc, and then d is not in that term, right? So it becomes 4bc times, okay, from this term, 4bc is outside, so we are left with 4a cubed from the first term, minus, looking at this, 4bc is outside, so we are left with 3, right? Because 3 times 4 is 12. 3ab squared d. 3ab squared d from this term. Okay, because 4bc is outside. And from this term, 4bc is outside, we are left with b cubed c d squared plus b cubed c d squared. Okay, and that's then the factorization of that. So you can decide to maybe factor further by considering these two terms and factor out a, or these two terms and factor out d, but it won't make any huge difference doing that. Okay. Okay, let's look at number 7 now. Number 7 says factor completely z squared minus 49. Okay, so looking at this, I see a z squared there and I see a number 49. Now, there is no common factor here, so greatest common factor cannot be used on this problem, all right? Clearly, this is not a difference of cubes. This is z squared and not z cubed. It's not a sum of cubes because this is a plus, a minus, and not a plus, all right? So difference of squares, we are then left with difference of squares as our only option for simplifying this expression or factoring this expression. Okay, so I look at how can I write this as z squared minus something squared, right? So I ask myself, 49 is the square of which number? Okay, so 49 is the square of 7. So I can rewrite this as z squared minus 7 squared. And it becomes a typical difference of squares that I can quickly apply my difference of squares formula. Okay, recall what the difference of square formula says. It says that x squared minus y squared will be the difference of the sum of these two terms times their difference. This is the difference of squares formula. Okay, so in this case, this is my x and this is my y. So if I apply the formula, all right, it's then going to be the sum of the two, which will be z plus 7, times their difference, which is z minus 7. Okay, and that's the complete factoring of that expression there. Okay, let's look at another example, number 11. 11 says 25y squared minus 4. Okay, so again, looking at this, 25 is the square of 5. 5 squared, y squared, 2 squared. Okay, so this tells me that this is a typical difference of squares. So all I need to do is to start by writing it as something squared minus something squared. So it will be 5y all of this squared minus 2 squared. All right. Once it's in this format, then this is my x in the formula and this is my y in the formula. So I just substitute these values into the formula for difference of squares. So it says add up the two numbers and multiply by the difference of the two numbers. So the first number is 5y plus 2 times 5y minus 2. Okay, and that's the difference of squares formula, basically. Okay, let's take another example, question 8, okay, which is x squared minus x minus 6. Okay, so clearly this is a quadratic expression. Clearly, we can all identify this as a quadratic expression, and we said the trial and error method is mostly used to factor quadratic expressions or expressions that take quadratic forms. So the best way, so just as its name suggests, you do this by trial and error. You keep trying and making errors until you get it right. All right. So the first thing is to look for two factors of this first term. All right. And factors of this last term. Okay. Which when you cross multiply and add, you get the middle term. Factors of this first term, you put them there. Factors of this term, you put them there. This times this plus this times this should give you this middle term. If that happens, then your factors will be as follows. F1 plus F11. All right, this is F11 and this is F22 times F2 plus F22, and that will be your factorization. Okay, that's how the trial and error method works. Two factors of the first and last term, which when you cross multiply and add, you get the middle term. Okay, so for this particular question, the factors of x squared will be x, and the factors of -6. Remember that we always read a number together with its sign. Okay, I will not stress this enough. You always read a number together with its sign. Common mistake would be to say this is 6, then you go and look for factors of 6. All right, this is not just 6, it is -6. So factors of -6 will be -3 and, or 3, let's say 3 and -2. Let's cross multiply and add and see whether we get minus x. Okay, x times -2 will be -2x plus x times 3 will be 3x, right? And our answer is x, but we are looking for -x. So that first trial did not work. Let's try again. So what can we do? So looking at this, I can see that if I swap the position of the negative sign and use -3 and 2 instead, okay, I might get my desired result. So you keep trying, okay, with these factors. If you don't get it with these factors, look for other factors. 6 and 1 are also factors of 6, of -6 and 1, and so on. So 2 times x is 2x. X times minus 3 is minus 3x. Okay, so 2x minus 3x gives me a minus x, which is exactly my middle term. So that tells me that my factors, right? My factors for this expression will be x minus 3, right? This x minus 3 times x plus 2. Okay, so realize that if you multiply out your brackets the way we saw how to multiply when we were doing multiplying algebraic expressions, okay, then you will actually see that that you get exactly this expression there when you multiply everything in like that. Okay, let's take more examples. So it's x minus 3 times x plus 2, basically. Okay, if we are taking more examples, then we are looking at example number still in 0.5. Still in 0.5, look at example 26. 26 says that 4x to the power 6 over 5 minus 1. Okay, so I'm looking at this. This looks to me more, 4 can be written as 2 squared, and 1 can also be written as 1 squared. So this tells me that I can actually transform this into some difference of squares by trying to write this as the square of something, right? If I manage to write x to the 6 over 5 as something squared, then I have transformed this expression into some difference of squares expression. Okay, so looking at this, I'll see that this will then be 2x to the 3 over 5 all squared, right? Minus 1 squared. Okay, so remember our law of exponents. X to the 3 over 5 to the 2 will be x to the 3 times 2 over 5, basically, which will be x to the 6 over 5. Okay, remember that law of exponent. We have this as one of our laws of exponents. Okay, so that said, we then move over to apply our difference of squares formula, which says that you add up the 2, which will be 2x to the 3 over 5 plus 1 times the difference, 2x to the 3 over 5 minus 1. And that's the factoring of that expression, basically. That's how that expression is eventually factored. Okay, we're taking more examples. Look at number 33. Number 33 says that x cubed, we're still factoring completely, minus 4x plus 8 minus 2x squared. Okay, and we want to factor this. So I'm looking at this and it doesn't look like a difference of squares or sum of cubes or quadratic. It doesn't look like any of those things. But if I look at my first bracket there, I have a common factor, which is x. So maybe if I start with that, then I can see. And in my second bracket here, my common factor there is 2, right? So if I take out x from the first bracket, I'm left with x squared minus 4 plus take out 2 from the next bracket, I'm left with 4 minus x squared. Okay. So I have this difference of squares now. Okay, so you see how at the beginning it didn't really look like anything familiar, but just by applying method 1, we now see familiar things. All right, difference of squares, difference of squares. So x can stay outside. I apply my difference of squares formula on this part. It gives me x plus 2 times x minus 2 plus 2 can stay outside. Apply my difference of squares formula. Gives me 2 minus x times 2 plus x. Okay. And looking at this, I can see that x plus 2 is common to both terms. All right. I can also still factor it out. X plus 2 into x times x minus 2 plus 2 times 2 minus x. Okay, and that's that. I think we can end it here, even though we can still rewrite this as negative x minus 2. Okay, so it becomes x plus 2 is outside. We have x times x minus 2 minus 2 times x minus 2, basically. All right, 2 minus x, we can factor out the negative sign and write it as negative x minus 2. All right, because if the negative sign comes into the bracket, this becomes negative, this becomes positive, just like it is here. Negative, positive. Okay. So that's how I changed from 2 minus x to x minus 2. So then x minus 2 is then common to both terms. So I get x plus 2 times x minus 2 into, in the bracket, I'm left with x minus 2. Okay, so the whole thing then boils down to x plus 2 times x minus 2 squared. Okay, and that's the complete factoring of that expression there. Okay, we'll continue in our next video.